All right, I'm going to walk you through some of the exercises, some of the homework, if you are curious. We're going to start with problem number 1, which has some scores on a math test, and we need a frequency table. Okay, so again, frequency table has the description on the left and the frequency on the right. So these are scores on a math test, and then frequency. It doesn't specify whether it wants the relative frequency, but we're going to make a pie chart anyway. So we're going to include the relative frequency so that our pie chart looks a little bit better. So then we're going to go over to our data and look at what we've got. So again, we're going to order these in order. What's the smallest? Is it 50? No, there's a 30. Oof. Ooh, that poor person. All right, so there's a 30. And there's one of those. And then there are 50s. And there's 1, 2, 3, 4 50s. 60s, 1, 2, 3. There are 70s, 1, 2, 3, 4, 5, 6. There are 80s, 1, 2, 3, 4, 5. And there's also 90s and 100s. 90s, there's only 1. And 100, no, there's 2. See, that's why we cross them out. Make sure we count them all. And 100s is 1, 2, 3. So hopefully we have checked out every single box. That's why I mark them as soon as I've counted them. And then we add them all up. It's 2 by 2, 4, 6, 8, 10, 12. It should be 24 scores, hopefully. Let's count up and make sure these are 24. 5, 8, 14, 19, 21, 24. Great. So the total is 24. We'll divide each of these by 24 to find our relative frequency. No, not 1-800-Flowers. Google. 1 divided by 24. That's 4.2%. 4.17%. I usually include 2 decimals in my percents. Then 4 out of 24 is 1/6. 16.67%. 3 out of 24 is 1/8. That's 12.5%. 6 out of 24 is 25%. 5 out of 24, I have no idea. 20.83. 2 out of 24. Yeah, we used that number earlier. And 3 out of 24 is still 12.5%. So again, hopefully these numbers should add up to 100%. If you're worried, you could double check, type them all in, add up. Again, there are rounding errors, so it might not be exactly 100%, but it should basically be 100%. That is part A. That is our frequency table. And now we're going to go to part B, where we need a histogram. The y-axis is the frequencies. The biggest frequency is 6. I'm running out of room, but I want to do this on the same page. And then so we'll just say, okay, let's, maybe we'll have a little gap here. This is where 30 is. And then we're going to include 40, even though there's nothing in 40, because making sure that everything's the same distance. 70, 80, 90, 100. So 30, there's 1, 1, 2, 3, 4, 5, 6. Sometimes I make a big hash mark at the 5 just to make it a little easier if I don't have graph paper. So 30 is only 1. Make sure your histogram is connected. Well, 40 doesn't have any, so it's not connected to anything. 50 is going to 4. 60 is going to 3. 70 is going to 6. 80 is going to 5. 90 is going to 2. And 100 is going to 3. And again, you do a good job to keep these all straight and even, but Should just look something like this. On the homework answers, I did this with a computer, which will look a little different, but it should look pretty similar. All right. So part C is going to be a group of adults. Nope, that's number 2, a pie chart. So we're going to draw a circle, and each one of these is a certain size of the circle. So we're going to start with the biggest piece. 25% is a quarter of the circle, and that's going to be the people that got 70s. So 70 is 25%. I'm going to make a little note here that I already took care of that. Next one's 20.83. So that's about a fifth of the circle. This gets really hard when there's more of these. A fifth of the circle. So maybe like this. That's going to be 80s. It's about 21%. And we're going to run out of room on this very quickly, right? Next is going to be 50s, which with a sixth of the circle. A little smaller. I know that this is a bad idea to do by hand. This is going to look really bad at the end. I know it. 50 for about 17%. And then we have two 12.5s. So 2/8 of a circle are going to be 60 and 100. Eighth is half of a quarter. It's like this piece. So this is going to be 60 and 100. You could also have ordered these in a different way. This is about 12.5%. And there's an 8.3% and a 4 point something percent. Oh, this is just becoming this is the 90s and this is the 30s. This is just becoming like the example in the book where you're like, these percents aren't quite accurate. So these ones down here need to be a little bigger. So this one can be smaller. The 30 should be smaller. This is why you don't do these by hand. You could also just like type these into Excel. You get a much nicer pie chart, which is what I did in the homework answers. All right, so that's problem number 1. Let's look at problem number 3. Okay. A group of adults were asked how many children they have in their families. The bar chart on the right shows the number of adults who indicated each number of children. Okay, so how many adults were questioned? That's the total sample. Okay, so 5 adults had 0 children, 3 had 1, 4 had 2 children, 2 people had 3 children, and 1 person had 5 children. So we just add up all of those frequencies and get our answers. So 5 plus 3 is 8, 12, 14, 15. So 15 total parents or adults. I guess if they're adults, yeah, not parents, because the people with 0 children are not parents. What percentage had 0 children? So that's relative frequency. So 0 children, there were 5 of them. So 5 out of 15, find that as a percent. It's 33.3 repeating percent, or about 33.33%. That's all you have to do for number 3. I wanted to look at 14 a little bit as well. We have this graph on the bottom showing the number of adults and children who prefer each type of soda. There were 130 adults and kids surveyed. Some ways could improve the graph. What's one of the ways that we can improve the graph? So in terms of strict readability, I think 2D graphs are easier to read than 3D graphs. However, 3D graphs can be really popular, especially in some corporate environments, because they look fancier. They're harder to read, but they look fancier. Okay, and so it just kind of depends on what you're going for. Are you trying to impress people in suits? Are you trying to have very exact data? So improve is subjective in this case, right? Obviously, I'm a math professor, so I say, it needs to be really clear, right? But there's some reasons. Let's see, what are some other ways in which the graph could be improved. You know, there's a difference between the colors, right? It's showing the kids and the adults. You can very easily tell which one's which. So I think that's easy to see. Here's something that, again, is also a little controversial. It's exaggerating a little bit maybe. But notice that the y-axis, this is not 0. The x-axis is not a y value of 0. All right, so that can be misleading. It looks like almost nobody that's a kid is drinking Diet Coke, when in reality it's like 22%. Okay, so that's what I mentioned earlier, where you sometimes see like this little, I can't draw straight lines, but you see the little jaggedy line, which shows that, yes, there's a big gap here that we're not showing. So maybe having a jaggedy line below that 20 could be helpful, or maybe we just start at 0, okay? But that can maybe make it a little bit more clear. Currently, it's a little misleading, but it's not incorrect. And that's a big distinction. Misleading, but not incorrect. So those are the two things that jump out to me. I'm sure there are other things as well that you might notice yourself, but I'm not going to spend too much time on this video looking at other things. But those are the two things that jump to me. Again, it's not wrong. It just depends on what you're going for, how you're trying to mislead people, which is one of the reasons why statistics gets a bad rap. Anyway, good luck. Hopefully this helps with those problems.